Okay, what we are going to do for the next few minutes is have a quick recap of probability. Right, so probability is on paper 2 of your Leaving Cert paper. In terms of probability, there's some important things you need to know. Okay, in terms of probability, all your answers should add up to 1. So if you work out a probability and you get a number bigger than 1, you're wrong. Check what you're doing. For example, sometimes they give you Venn diagrams and they ask you, what's the probability of somebody doing something? And you read the number off the Venn diagram. You're not meant to read the number off the Venn diagram. You're meant to put the number over the total for the Venn diagram, so you get a value less than 1. So make sure, again, probability answers cannot be more than 1. You cannot be more than 100% certain that something will happen. Okay, how you work out the probability of an event happening is you work out the number of times the event will happen over all the possible answers. So, for example, if you're saying how many times will you get the number 2 on a dice, you get the number 2 once, so you'd write the event happens as 1. Possible answers, your dice should have 6 sides on it, so you'd have 1 over 6. The probability of an event not happening, you can either work out the amount of times the event doesn't happen and work it out the exact same way as up here, or the possibility the event doesn't happen is simply 1 take away the possibility that the event did happen. Okay? In terms of questions, sometimes they ask you for expected values, right? Normally these questions will involve casinos, and they will say you're playing a game, you're spinning a spinner, you're throwing a dice. You will win a certain amount of money. What is your expected winnings? What are the expected value? How you work it out is you work out the probability for every time, multiply it by the money or the wins every time, and then add them up. So if you're doing it by a dice, you will have 6 probabilities times money and add up the 6. Okay? If a game is fair, your expected value should be the same amount it costs the person to play the game. If it's not fair, it could be biased towards the organizer of the game. So in other words, the player is guaranteed to lose. Or it could be favorable, right? In fact, that the player is guaranteed a win. Okay? Next silly little thing they ask you are things about Bernoulli trials, right? So for Bernoulli trials, because it is a project maths paper, you need to know the definition for a Bernoulli trial. If you have something and it's a Bernoulli trial, you are doing something where there is only 2 answers. For example, you're throwing a dice. You can get, flipping a coin. You can either get a head or a tail. Okay, if you're throwing a dice, you either get a number, a particular number, for example 2, or you don't. Right? You are spinning a disc and you get one of 2 colours. You're kicking a penalty. You get it or you miss. Right? So you only get 2 answers, and each trial has to be independent. So the fact that you did something once has no effect on the possibility that you're going to do it a second time. Okay? So that's them. Then a few more little bits. So we have, just move this. There is something called the fundamental principle of counting. Right? You need to know the definition for the fundamental principle of counting. So if you can do one job X ways and another job Y ways, you can do both jobs X, Y ways. Okay, and you need to learn that off. If you are given events and the events are dependent on each other, so they are not Bernoulli trials, when you work out the probability, you have to subtract lapovers. So, for example, we can have you have people on a football team and people on a basketball team, but you have people on both, right? So you would have to subtract the overlap. In probability, if a question asks you something like you're repeating events, so you've got 2 spins of the dice, 2 throws of whatever, right? If you have to get both, it's counted as an and. So what you do is you multiply the probabilities. And if it's you do one thing or the other, you add the probabilities. Okay, so normally when we think of and, we think of plussing, but for a probability, if you have to do one thing and another, you're multiplying. Okay, and then a favourite of lots of yours, if they ask you for choices and combinations, use 3 diagrams. So your tree diagram was over here. Okay, that would be a tree diagram. You were doing something and you have 3 options, right? Or 2 options or 4 options. This one we have 3. So in this case, the person is choosing medals and they can get a gold, a silver, or bronze. When they get the second medal, they can get a gold, a silver, or bronze. Third medal, a gold, and silver, and bronze. So you could work out a tree diagram like that. Okay, and that I got lazy and didn't complete the whole thing. Try another tree diagram. No. Okay. And finally, just fix this again. Sorry. Sometimes in probability, there is a part which is to do with permutations and combinations. Basically, how many ways you can make your PIN number, how many ways you can make a password, how many ways you can make a team, how many ways can you put people standing in a photograph. Okay? In terms of doing it, the easiest way to think of them is to think of boxes, right? If you're making a PIN number and you are allowed to use any number as many times as you want, you are allowed to repeat them, you imagine boxes. So if I was making a PIN number with the digits 0 to 9 and it had 4 bits in it, so between 0 and 9, I have 10 digits, right? So I would have, if I'm making a PIN number and it's got 4 bits, you'd imagine you've got 4 boxes. Think of the keypad when you're typing in your PIN numbers on the ATM, right? Into the first box, we can put any number between 0 and 9, so that means the choice of 10. In the second box, I can repeat. If I wanted, my PIN number could be 0000, right? So I could have 10 again. I could have another 10, and I could have another 10. So in terms of this, how I can make a PIN number using the digits 0 to 9 with 4 parts in it, I have 10 to the power of 4, which is 10, or 1 with 4 zeros afterwards. So I have 10,000 options. Okay? If you are not allowed to repeat, right, you can use your NPOR button. So if I was making my PIN number but I wasn't allowed to repeat them, if I use the box method, I'd still have my 4 boxes. But my first one, I have the option of 10 things, then I'd have 9, then I'd have 8, and then I'd have 7. Right? I could remember that and multiply them out. Or on your calculator, there is a symbol which says NPOR. Let me show it to you now. So on the calculator, you see these? It is, it's not focusing. It's above the multiplication sign, that's NPOR, and above the division sign is NCOR. So if I'm doing PIN numbers, think of PIN numbers having the letter P, we're doing the NPOR button. So if I had 10 digits, I'll show you now. If I had 10 digits and I wanted to pick 4, I go 10, shift button, multiplication sign, 4, press equals, and I get 5040 is my answer. That is the exact same as going 10 times 9 times 8 times 7. Okay, just a shorter version. So for your P, for your picking button, it's permutation, the order is important. Alright, so if I'm making my PIN number, I want my PIN, if I had 1, 2, 3, 4, to be different than if someone typed in 4, 3, 2, 1. So the order is important. If the question asked you about teams, alright, so you're either making a team or a committee or something, and you want to choose like head boy, head girl, captain of a team, vice captain, things like that. The order doesn't count, so you'll use a combination, not a permutation, right? So you'd use your NCOR button. So if I had 10 people and I wanted a subcommittee of 7, right, I would go 10C7. Alright, so on the calculator, you go 10, shift button, division button, 7. So if I had a group of 10, I want a committee of 7. My choices for working out that committee are I can use 120 different ways. Okay? In terms of questions, these two methods, your NPOR and your NCOR, will come up with the idea of choosing, arranging people to make photographs, or choosing books, or choosing something like that. Okay, so I hope that helps. It may or may not. Alright, so in terms of questions, okay, I don't have the questions with me, but I have the rough idea. Alright, so if, for example, you were going out for dinner, these are just sample questions which have come up over a few things. So if you're going out for dinner and the restaurant you were going to had 5 starters, 6 main courses and 4 desserts, the question is, how many ways can you choose your meal? Alright, this, you've got 3 different jobs. You can do the first job 5 ways, the second job 6 ways, the third job 4 ways. So this is your fundamental principle of counting. So how many ways you can choose your dinner is you simply go 5 by 6 by 4. Multiply them out and you get 120. So there are 120 ways you could choose your dinner. Okay, for pin number 1. Okay, so just ignore the phone ringing for a sec. Okay, I'm just going to keep talking. Alright, so if you have 0 to 9, as we were saying, 0 to 9 is actually 10 digits. If you want a 5-digit pin, right, you can either use the button 10, pick 5. And you just type that into the calculator and you get 30240. What you are doing there is you will have 5 boxes. In the first box you can have 10, then you can have 9, then you can have 8, then you can have 7, then you can have 6. For using the pick button again, remember, repeating is not allowed. Okay? So when we have our 10, 9, 8, 7, and 6, and we multiply them all together, we would get the same answer. Right? Another question they had was, we had 3 boys and 3 girls and we want to arrange them in a photo. Right? In terms of the photo, I want all the boys together, and I want all the girls together. Right? So, to arrange my 3 boys, I have 3 boxes. First box, I have the choice of 3 boys, 2 boys, 1 boy. So I go 3 times 2 times 1, which gives me 6. Alright, for the girls, exact same idea. I've got 3 girls, so 3, 2, and 1. So I've got 6 options. Right? So that means arranging the boys and the girls, I have 3 boys and 3 girls. So and means multiply. So I go 6 by 6, which gives me 36. And then in terms of my arranging people, I can either go boys first, followed by girls, or girls followed by boys. So I will have 36 plus 36, or 36 times 2, which means I have 72 ways for arranging these kids for a photo. If, on the other hand, I wasn't fussy and I wanted to just stick those 6 kids in a photo, you ignore the fact that they're boys and girls and you would say that you have 6 people. Right? So how many ways can you arrange 6 people for a photo? So that will be your 6 by 5, by 4, by 3, by 2, by 1, which on your calculator is 6 factorial. Alright? And you work that out. So if I'm not fussy about who stands beside who, I can arrange it 720 ways. Okay? Alright, so on that, I'm switching this off before it switches in. Hope I didn't traumatize you too much.